So here we need to prove that we have an expression 1 over sp plus 1 over sq. This is a constant and it does not depend on the variable t. So here we are provided with 3 points p, q and s, and for each of the 3 points the coordinates are also provided to us. Let us begin. So here let's say we randomly choose 3 points on this particular plane. We have point p, we have point q, and we have point s. So we're just scattering it over the surface of this particular plane. So here point P, let's say this has the coordinate given by at squared and 280. This is already provided to us. So P corresponds to at squared comma 280. Then we have point Q. So this corresponds to a over t squared. That's the x coordinate, and the y coordinate is 2a over t. Fine. And then we have the point S. The point S has the coordinate a comma 0. Now what we'll do, we'll join point A and point B, point P and point S, and we'll also join point Q and point S. What we'll do first, we'll try to find out the length of each of the two sides. We'll try to find out the length of both PS as well as QS. For that, we'll have to take the help of the distance formula. Let's specify the distance formula. So let's say we have 2 points, point A with coordinate x1, y1 and point B with coordinate x2, y2. Then if we join them by a straight line AB, so its length is going to be given by square root of, so underneath the square root, first we take the square of the difference of the x coordinates, so that's x2 minus x1, and then we take the square of the difference of the y coordinate and we sum the two values. So this is how we can use the distance formula. So let's begin by finding out the length S. So SP will be equals to, first we'll take the square root. So underneath the square root, so since we are doing SP, so we'll start with P and from it we are going to subtract S, meaning we'll start with the x coordinate of point P. So that's AT squared, and from it subtract the x coordinate of point S. So that's simply A. So we have AT squared minus A whole squared. Then we'll add it to the difference of the y coordinate. So we'll start with the y coordinate of point P. So that's 280. And from it, we're going to subtract the y coordinate of point S. So that's simply 0. So we have 280 minus 0 squared. Let's simplify. So underneath the square root, now we have AT squared minus A whole squared. We're going to expand it by using A minus B whole squared. So that's simply going to be AT squared whole squared. Then we have plus A squared minus 2 times AT squared times A. And then we have 280 whole squared because 0 doesn't count here. So 280 whole squared will be 4 times a squared t squared. So this will be equals to, so we have square root of a t squared whole squared plus a squared. Now negative 2at squared times a, so this a and this a is going to get combined to give us negative 2a squared t squared plus 4a squared t squared. So that means we can combine the third and the fourth term. So we get square root of at squared whole squared plus a squared plus 2a squared t squared, and this is nothing but simply at squared plus a whole squared. It's the expansion of at squared plus a whole squared. Now it's at squared plus a whole squared means it's a perfect square, so we can get rid of the square. But so this is going to give us at squared plus a. So that's the length of SP. Fine. So we can take a as the common factor. So we have a times t squared plus 1. Now coming to the other length SQ, we'll apply the distance formula here as well. So SQ is going to be equals to, well, let's label this as equation number 1. So SQ will be, we'll have to first start with the square root. Underneath the square root, here we will take the x coordinate of Q first, so that's a over t squared. And from it we are subtracting the x coordinate of S, so that's simply a. So we have at squared minus a, and then we square it. Then add it to the y coordinate of Q, so that's 2a over t, and from it we're subtracting the y coordinate of S, so that's 0, square it. And this is going to give us, so we have square root of, so let's expand it, we get a squared divided by t raised to the power of 4 plus a squared minus 2 times, so at squared times a, that will be simply a squared over t squared. This will be added to, so 2a over t minus 0, that's simply 2a over t whole squared, so that gives us 4a squared over t squared. Further simplification is now going to give us, we have square root, underneath the square root we have a squared divided by t raised to the power of 4 plus a squared plus 2a squared over t squared. Now this is nothing but the expansion of a over t squared plus a whole squared. Now we can get rid of the square root and we are left with a over t squared plus a. So we have obtained the value of sq as well. So sq comes out to be, so we'll take a as the common factor. A will be multiplied to 1 over t squared plus 1, or simply we have a over t squared. So this is multiplied to 1 plus t squared. So let's label this as number 2. We now have the length sq as well. Now we'll obtain the value of 1 over sp and add it to 1 over sq. So we have 1 over, so what's sp? We have obtained sp is simply a times t squared plus 1. That will be added to 1 over sq. So sq is, so we'll have to take the reciprocal of sq. So that's simply a times 1 plus t squared. So the t squared in the denominator will move to the numerator. Fine. So let's combine them. So we have a multiplied to t squared plus 1, that's the common denominator, and the numerator we have 1 plus t squared. So 1 plus t squared plus 1, that cancels out, and we are now left with 1 over a. Now clearly we see that this expression 1 over sp added to 1 over sq is giving us a value 1 over a, and it does not have any parameter t. So that means it's independent of the variable t and it's simply a constant. So we have successfully proved the problem. Yes, the expression 1 over sp plus 1 over sq is a constant and it does not depend on the variable t here. So that means although it's not specified here, a is a constant, whereas t is not a constant, it's a variable.